Good morning.
A very good morning, sir.
So, shall we start?
Sir, just 5 minutes, sir.
Okay.
You can start.
Okay. Good morning, one and all. And I welcome you on behalf of KVSR Siddhartha Pharmaceutical Sciences for third day of FDP on holistic approaches, disease treatment, regulations, and pharmacological strategies. I would like to call upon HOD of Pharmacognosy and coordinator of the program.
Thank you, Kushal. Good morning, one and all. Sir, good morning, Hemant Garu.
Good morning, ma'am.
Sir. I welcome all the participants to this third day of our faculty development program on holistic approaches towards disease, treatment, regulations, and pharmacological strategies. Today, we have an eminent speaker, Dr. Hemant Sir from Naipur, Ahmedabad. Thank you, sir, for accepting our invitation.
It's my privilege, ma'am. Thank you.
As we all know, any drug discovery is incomplete without the usage of animal models. Even though a number of in vitro methods and in silico methods are available, still the role of animal models is valuable and it cannot be replaced completely. So, sir is going to highlight some of the facts related to the animal experiments, animal handling. And sir is well versed with all these pharmacological experiments. And I request all the participants to interact with sir and to clarify your doubts at the end so that during the drug discovery process, whenever we do the experiments, a number of problems will arise. So those problems can be answered by people who have experience in this type of field. And sir is well versed and well experienced in this field. So I request all the participants to utilize this platform and get new ideas from sir. Thank you, sir.
Thank you.
Over to Sushant.
Thank you. Thank you, ma'am.
Continue.
It's my great pleasure to introduce such a novel personality as our today's speaker, Dr. Hemant Kumar Sir, Assistant Professor, Department of Pharmacology, Naipur, Ahmedabad, India. Sir did B Pharmacy from Manipal University, M Pharmacy from BIT Master of Pharmacology. After completion of the Masters, he joined Landmark Research Center, Mumbai, and worked in in vivo pharmacology department in areas of neuropathic pain, arthritis, and schizophrenia for around 3 years. He has also worked at TCC Life Sciences, Kolkata. As a senior research biologist, 1 year in vivo pharmacology. In 2011, he moved to South Korea for PhD and postdoc. And he worked as the assistant professor in South Korea. He spent around 9 years in South Korea. And he came to India in Jan 2020 and joined in Naipur, Ahmedabad. And coming to the professional summary, pharmaceutical professional with 15 years of experience, including 4 years of industrial experience in vivo pharmacology and research and development area, and strong pharmacological background with special focus on neurosciences. His primary research areas is to find out the target of endothelial protection or stabilization within penumbral microvasculature and preventing the blood spinal cord barrier integrity. And coming to the publications, he had more than 50 plus more publications in reputed journals, including Journal of Neurosciences, Biomaterial, ACS, Nanoletter, and Advanced Health Material. And SAR had the total citations 2,779, and H index is 27, I index 42. Coming to the awards, SAR got awarded as KRF Korea Research Fellowship for doing postdoc 2015 to 2020, and he got Brain Korea 2021 award for the year of 2021 and 2012 and 2013 and 2012, 13 and 14. Weekly Academic Award from South Korea Spinal Neurosurgery Society, and he got Best Paper Award from Biospine Asia Pacific. Coming to the grants and patents, SAR completed 2 grants total worth 3.6 crores from National Research Foundation, South Korea, as a principal investigator, currently handling SERB SRG, Science Engineering Research Board, Startup Research Grant as a principal investigator, and SERB CRG, Core Research Grant as a co-principal investigator with a total worth 89 lakhs. 6 Korean patents applied by the SERB and one Korean patent granted. This is a brief note about Dr. Hemant Kumar sir.
Thank you so much. So should I share my screen?
Yes, sir, you can.
Okay. Not getting the option. Just give me 1 minute.
Yes, sir, you can.
Can I send you my PPT?
Yes, sir, you can.
Because I think there is some options which are disabled. So please,
So once check now.
yeah, wait.
Sir,
So I will send you, please share the email ID. I will send the PPT.
sir, you can send it to my mail ID, sir.
Okay.
Yeah, yes, sir. Sir, now you are co-host. You can share your screen, sir.
Yes. Okay. Karna ma'am, I have shared the PPT. Can you find it? Hello.
Hello.
Karna ma'am,
Sir,
I have shared you the PPT.
Yes, sir. Yes.
Okay. Please,
Yes, sir. I'm sharing.
yeah, because there is some, I think, technical glitch from, I don't know from where, but it's not allowing me to share the screen.
Okay, sir.
Yes, ma'am.
Yes, sir. 1 second, sir.
Yeah, please. Yeah.
Hemant sir.
Yes.
Sir, you are now co-host. You can share your.
Yeah, I was trying, but I think there is some technical problem. I think from my side, because there is anyway. I have sent the PPT to Karuna ma'am. She can share, and I will present. No problem. Ma'am, did you receive my email?
Yes, sir. I received, sir.
Yeah.
Not getting downloaded. That's why I'm waiting, sir. 1 second. Sushant? Sushant?
Yes, ma'am.
Sushant, I have sent it to your mail. Try to download it.
Oh, sure, ma'am.
Not downloading in my. It's taking time.
Okay.
Sure, ma'am.
Otherwise, I will call my IT people if there is any problem.
Okay, ma'am. I will download and I will share my screen.
Okay. Thank you so much. Sorry for this technical problems. It suddenly happened. I don't know why.
No problem, sir.
Yeah. Okay. I think we can see the screen now. Yes. Okay. So should I start?
Yes, sir. You can.
Okay. So first of all, thank you everyone, and it is a great pleasure for me to be present here. And today I will be starting briefly about the CNS injury. My main research area is CNS injury. I have worked mostly in neuropathic pain, inflammation, arthritis, and mostly traumatic injuries. I work in spinal cord injury, intervertebral disc degeneration, and multiple sclerosis. So today I will be focusing on spinal cord injury. What are the different kinds of animal models? What are the current treatment approaches, and also pathophysiology? And since this is a kind of a program where we are working for a pharmacognosy or natural products, so I will also present some slides related to one of the omega-3 fatty acid where I have worked and I have confirmed and checked the role of that in spinal cord injury. So before we start, I want to ask, am I audible to everyone?
Yes, sir.
Clearly audible? Okay.
Yes, sir.
Yes,
Thank
sir.
you.
You're audible.
So please move to the next slide. Next slide, please. Sushant? Yeah, thank you. So, as you all know, that central nervous system contains brain and spinal cord. And in spinal cord, we have different areas where we can sense the different kind of sensation. It can be pain, temperature, or any kind of pleasure. All are innervated by some kind of nerves. So spinal cord can be basically divided into different areas, mainly cervical, thoracic, lumbar, sacral, and coccygeal. And these are innervated by 31 pair of nerves. So usually you will see that at cervical area, it is a most sensitive area. And if any injury happened at cervical area, it will definitely cause disturbance in sensory function, including breathing and breathing problem, speaking problem. Sometimes it will cause full body paraplegia. So depending on the extent of injury, the spinal cord injury is categorized. And I can see that like people are still entering. So Kushan, can you admit them by yourself? Okay. So here we can see the spinal cord in two areas. One is top view and side view. In top view, you can see the blue area. That is a kind of vertebral disc. The middle area is nucleus pulposus and the side is annulus fibrosus. And we have spinal cord. And then we can move to the next slide. Yes. So as I mentioned to you, most of our sensation, let's say you wake up in the morning and you feel some kind of cold or hot. You wake up and you start walking. You are feeling some kind of sensation. These all are controlled by spinal cord and brain together. So we have different kind of dermatomes and myotomes. So dermatomes are a kind of skin innervation at the single spinal cord level. So clinical conditions can confirm the specific area of the skin. We can also confirm which part of the spinal cord is damaged just by checking the innervation at that particular level. So usually clinician confirm this, that injury is at lumbar, sacral, cervical or thoracic level. So we can move to the next slide. Okay, so spinal cord injury is any kind of injury to the spinal cord. It's very simple definition that any injury, it can from either from fall or from road accidents or during kinds of any kinds of sports injury. So spinal can got damage, and depending on the level of injury, the patient will experience tetraplegia, quadriplegia, hemiplegia. So globally, the motor vehicle accident, or we can say road accidents, are the major problem or major cause of spinal cord injury. And after that, some kind of fall, everyday fall. Some people are doing hiking, mountaineering, so they get fall, and also they will get spinal cord injury. So this is a global data. And if we move to the next slide, we can see the Indian perspective of spinal cord injury. So in India, if you see, the highest cases of spinal cord injury are in Jammu and Kashmir and Ladakh region. So probably you can expect that the area is quite hilly, and also there are a lot of clashes. There are a lot of fights, rights, and kind of so it is one of the main reasons why Jammu and Kashmir and Ladakh have the highest prevalence of spinal cord injury, followed by Tamil Nadu. So Tamil Nadu mainly have higher in road accidents. So usually if you see, the most important aspect of traumatic injury is that the people or the patient who got affected are very young, because mostly if you see any neurodegenerative diseases like Alzheimer disease, Parkinson disease, you will find old population more than 60, 65. But in case of traumatic injury, the average age is 34. So they are quite young. So if we see in Indian perspective, the age lie between 20 to 49. But if we take the average global age, it is around 34 years. So the people who experience spinal cord injury are quite young. And currently we don't have any specific treatment for spinal cord injury. There are some kind of approaches. I will be discussing them one by one in my next slides. So if you see here, the males are having more chances for spinal cord injury. The reason is that because the most of the, even I will not be saying I am biased, but it is the truth that mostly if you see the rash driving cases, or it is mostly male are driving. Most of the sports injury are caused to male, mountaineering fall. So that's why the males are more like prevalent for spinal cord injury. So you can see males are approximately 4 times having higher chances of getting spinal cord injury compared to the female. And probably if we see after certain year, if everything will be normalized, probably we will have better ratio, or maybe we have like different ratio. But currently, as per the 2019 data, the males are having 4 times higher incidence or chances of getting spinal cord injury. So if we move to the next slide, we can see the basic pathophysiology of traumatic injury. When I am saying traumatic injury, I am mainly focusing on CNS injury, because CNS have traumatic brain injury and traumatic spinal cord injury. So out of spinal cord, we are mainly focusing on traumatic spinal cord pathology. There are some non-traumatic pathology also, where something like tumor occurs inside the spinal cord. That is a different kind of pathology. But today I will be focusing on the traumatic one, which are caused by mainly road accident or falls or mountain or these kind of things. So basically, if you see here, the upper side of your slide, you can see one cartoon. This is a kind of illustration I made after injury. So you can see there is a red injured area. We call it epicenter area. Epicenter area. And if you see above the epicenter is the rostral area, we call scientifically, and below injury we call caudal area. So if you see, whenever there is an injury, that particular area got damaged, or you cannot see any neurons which are going in between that line. So this whole damaged area will be having no neuronal connection. So the upper neurons cannot communicate with the lower neurons because of the injured area. And this injured area will become big after a certain period of time. So we call that secondary phase. So if you see the illustration, you can see immediately after injury, neutrophils are the first cell to arrive at the injured area. So once neutrophils arrive at the injured area, you can see the blue bell-shaped diagram here. So blue represent neutrophils. So neutrophils usually peak at 24 hours after injury, and after 24 hours, the like they gradually goes down. By day 10, you will not expect any kind of neutrophils, but the peak is around 24 hours. But the important thing here is that neutrophils are the first cell to arrive at injury site, and once they come, they will release cytokines, chemokines, MMPs, and also these cytokines, chemokines, and MMPs will change the pathology. They will change the pathology of the spinal cord. And probably all of you are from pharmacy background, so I believe all of you know about blood-brain barrier and blood-spinal cord barrier. So they are a specialized endothelial cell which are having tight junction. So once any trauma or mechanical injury happen, this endothelial cell breaks, tight junction degrade. So we can see the disruption of blood spinal cord barrier, increase of neutrophils. As I mentioned to you, when neutrophils come, it always release cytokines, chemokines. So when cytokines, chemokines are there, we can expect lot of inflammation. So one can expect a strong inflammatory phase in acute during, let's say, from immediately after injury, let's say till 3 to 4 days, very strong inflammatory phase. And then once the inflammation occur, they recruit more macrophages from outside and also activate the resident microglia. So one can expect lot of microgliosis. Also, the neuronal cell which were present before injury and after injury, there is a mechanical damage or trauma. After that, the neuronal cell which were originally present will undergo apoptosis. They will eventually die, and macroglia will come, try to eat it, engulf it. Microglia also engulf the myelin debris, which is already published and reported last 2 years ago. Very strong paper. So we can expect from this current pathophysiology that after spinal cord injury, strong inflammation at acute phase, very high concentration of neutrophils, disruption of tight junction, blood spinal cord barrier, increased apoptosis of neuronal cell, higher microgliosis, and microgliosis followed by astrogliosis. So usually what happens, if we see the cartoon on the top, you can see one red primary injury. That is a primary injury area. On the side, you can see some blood vessels. So these are the damaged blood vessels. So if you see here, you can see some green cells which I draw. These are the glial cell. So basically, these glial cell try to protect. Basically, if you see, they try to prevent the further damage. But if you see during this uh, course of time, the cystic cavity, that is a central area inside the glial scar, it becomes fibrotic. So we can expect lot of fibrosis and gliosis. So this lead to the formation of glial scar. So the glial scar, even though it is coming to protect the body, but it is a major hindrance for the neuronal cell. Neuronal cell will not able to communicate because of the presence of glial scar. So several paper have published and shows that if we can inhibit the inflammation at early phase, we can reduce the glial scar formation. Also, people have shown that we can decrease the glial scar formation by different approaches. So just to summarize this figure, I will say any traumatic injury, including traumatic brain injury or traumatic spinal cord injury, mechanical trauma at that particular area will define the injury. It can be cervical, thoracic, lumbar, caudal, whatever. But the pathophysiology will remain same. Immediately after injury, one can expect higher number of neutrophils at injured area, higher, very high inflammation, disruption of tight junction, disruption of blood-brain barrier, blood spinal cord barrier, apoptosis of neuronal cell, microgliosis, astrogliosis, which may lead to the formation of glial scar. And this glial scar is major hindrance for the neuronal cell. So if we move to the next slide, we can actually see what are the current treatment approaches for spinal cord injury. So usually if you see, the best known approaches is decompression and stabilization of the spinal cord. Previous slide. Yes. So the best options are decompression and stabilization. So if you see here, the current drugs which are used are mostly steroids. Methylprednisolone is one of the drug which is used and also approved by FDA. But the problem is it is having some side effect. Second thing is methylprednisolone should be used within 8 hours. If clinician delay the treatment beyond 8 hours, it is not useful, because as I mentioned to you, the initial phase is very, very important for the spinal cord injury. So there is a concept, time is spine. So time is spine means that timely treatment is really crucial for spinal cord injury. So if we want something to be very successful, or if we want some drug to be very effective, it should work before, we should be giving it early as possible. So that's why the most of the methylprednisolone or steroids are given within 3 hours or not beyond 8 hours. So the ideal time window is 3 hours or maximum till 8 hours. Apart from drugs, there are many kinds of approaches. Hypothermia is one of the approach which is used clinically. Then apart from this main treatment of spinal cord injury, as I mentioned to you, spinal cord injury innervate everywhere. Spinal cord nerves innervate everywhere. So after injury to the spinal cord, this innervation will be affected. So one can expect the problem with the urinary outflow, bladder problem, sexual problem, other kind of which are directly connected to that particular area of the spinal cord. So one can have lot of issues in dealing with those problems. So apart from main treatment, the hospital care will be given, including the oxygen therapy, drugs, painkillers, and also other like stool thickener, thinning agent. So many other approaches will be given. So these are the one aspect of treating the spinal cord injury. But if you move from the traditional approach and move to the newer approach, one can find stem cells as one of the major, like from last 10 to 15 years, many papers have been published in this particular field. So one can expect a lot of like promising results from stem cell. But also, as I mentioned, there are certain problems and drawback with the stem cell. As I mentioned to you that at early phase, the inflammation is very strong. So at that time, we will see that stem cell usually, because of inflammation, they will die. And to protect the stem cell, we need to have some kind of protective materials. So that's where the approaches of tissue engineering, biomaterials come into the picture. So usually researchers try to incorporate the stem cell inside the scaffold or biomaterial and then transplant it to the injured area. So if we move to the next slide, so we can see the different kinds of animal model and how we can create a model of a spinal cord injury. So basically, we have many kinds, but if we see clinically relevant, contusion and compression, these two most clinically relevant animal model, if you see, because road accident mostly cause contusion and compression of the spinal cord. So most paper which are published in the field of spinal cord injury focus on the model of contusion or compression. But if someone want to confirm the role of biomaterial or scaffold, then transactions or hemisections are preferred compared to contusion and compression, because we need some space to put the scaffold. That's why we need to have uniform injury. So that's why we prefer hemisection or transaction. Apart from that, there are certain chemicals which can cause injury. If you can like think of glutamate, it can cause excitotoxicity. So if one can inject glutamate, it can also cause an animal model of spinal cord injury. So to summarize this slide, I can say contusion and compression are the most relevant model of spinal cord injury. If one want to study the scaffold or biomaterial, then hemisections or transaction are much better. Okay, so if we move to next slide, I will be here. You can see, as I mentioned to you, that there are certain kind of injury which are complete and some are non like incomplete. So you can on the your right hand side you can see three images. So in three images you can see central cord, anterior cord, and the last one image, that is the brown sequoia syndrome. That is the classical example of hemisection injury. So whenever we plan to have animal model, why we want to design them and what are our goal? The important is we should be focusing on our hypothesis. If your hypothesis is around cell death or neuroprotection, you should be checking a model where you can check the cell death, you can confirm the white matter sparing, you can have any method to measure the neuroprotection. Also, we should be able to create axonal injury, and I'm sure that any spinal cord injury model, including contusion, compression, hemisection, transaction, chemical, all of them, they can cause axonal injury. So if you see how much degree or extent may vary. If you want to completely remove the neuronal cell from one particular area, then full transaction of the neurons is recommended. But if you want to study only certain kind of injury, you can control the injury by different kind of instrument which are available. There are companies like NYU Impactor, which is a very good instrument. Apart from that, you can also get some instrument from RWD Life Sciences, and also you can customize them as per your requirement. So basically, the concept is very simple. You have an you have to create an animal model of injury. Now you need to focus on the extent of damage. So you can control different, you can have different weights. You can have 5 gram, 10 gram, 20 gram, 30 gram, mild, moderate, severe injury. You can also use some kind of clip, forceps, compression of the spinal cord. So basically, designing animal model is totally depend on our objective and hypothesis of the study. So depending on that, we can design the animal model. And if we move to the next slide, if it plays, can you play this slide? Is it possible? Sushant?
Sir,
Can you play? This is a video if possible. Otherwise, we'll move to next slide. Okay, anyway, so move to next slide then, if not working. So this was an example. This I put a video here. Since I send you this PPT, so probably it is not working because I believe. Okay, you can see some. Okay, I guess it will work. Okay, so this is a first you observe this, then I will speak.
can I pass?
Okay, so just now you have uh, observed the contusion model of injury. So in contusion model, we usually have a weight which is dropped from certain height, let's say 10 centimeter, and we already know the weight. We can control the weight from 5 gram to 80 grams depending on the severity of injury. If we want injury to be very severe, we can increase the weight and we can increase the height. So this is a classical example of contusion. But if we want to replace contusion from compression, so instead of dropping the weight, we will be compressing the spinal cord either with the forceps or with the clip. There are many kinds of aneurysm clip which are available in the market. So one can decide. So usually you can also confirm or you can also create animal model at certain level. Let's say you want to study cervical injury. So you have to open and expose the cervical spinal cord. So currently in the video what you saw, it was a thoracic T10 level, thoracic 10 level. So we can create different animal model of spinal cord injury depending on our study hypothesis and our objective. So if we move to the next slide. Okay, so usually when we have any kind of injury, we can see some kind of functional impairment. So usually if you see most of the patient with spinal cord injury, they have to use wheelchair. They cannot walk. So the functional recovery is impaired. There are a lot of issues in walking. Some people have partial, some people have full forelimb, hind limb, both are affected. So in here, if you see here, the images B, you can see animal is normal and it's walking. So always remember, whenever animal is normally walking, tail is always up. This is a normal tendency of animals. The tail will be always up, and it will have certain kind of motor coordination. The left and right legs will move together, and we call it straight line. So you can confirm that in normal condition. Go back, yeah. And in C, if you see the image C, you can see a contused animal at thoracic area. So the animal is having paraplegia, not tetraplegia. It is paraplegia, hemiplegia, but not tetraplegia. Four limbs are still okay. And you can see the tail position. Tail is flat, flaccid. So this is a classical example. If you follow any kind of animal model of spinal cord injury, you may have varying level of functional impairment. So depending on the animal model you use, you need to make sure the correct post-operative care. As I have mentioned, that once we are working in any traumatic injury, the post-operative care is really, really important. Because usually what happens, the researcher, whoever work in this particular field, they already know that once you do injury, animal cannot do most of the things. They cannot urinate. You need to help them in urination. So you need to press their bladder at least 3 to 4 days, early days, till the time their bladder reflex become normal. So you need to assist them. You need to do press. You need to press the bladder. And post-operative care also include, in case of animals, I am talking about changing the bedding every day, morning and evening, checking whether is there any hematuria, there is any blood or pus formation in the urine. Depending on that, you need to use certain antibiotics. You need to use certain painkillers. So these all are a part of post-operative care. Also, you need to like inject saline so that the animal will be having faster recovery. So these are some basic approaches. So if we move to next slide, we can, yeah. So here I want to show how a typical injured animal will walk. If you color the hind limb and forelimb of the animal with different color, you can easily track them. That let's say right hind limb is red and left hind limb is purple. Then you have forelimb. You can label them black or blue, and then you need to make them walk in a straight line. And once they walk, injury animal, you can see by day 21 or day 14, you can see certain improvement in injury, the normal recovery of injury in case of contusion or compression model. If you have a good treatment, you will have faster recovery compared to the injury group. Second thing is, the whenever you are saying recovery, we have to focus on the stride length also, and also the motor coordination. How animal is walking, whether the movement is well coordinated or not. So this we can confirm with simple experiment. This simple experiment is called footprinting. So this can be done manually. Any lab can do this, but if you want to have more sophisticated and more reliable and less painful experiment, because this require a lot of effort, you need to have lot of white paper with you, you need to have different kinds of inks, you need to hold the animal, label their forelimb, hind limb with different colors, you need to make them walk in a straight line, and then you need to scan these white papers using a scanner, then you need to do the analysis on these scanned images. But if the lab is rich or the fund is not a problem, there are many instruments which are automated. So this is a catwalk. There is an instrument called catwalk. So where you can assess everything automatic. You don't need to do anything manually. You just need to place the animal, and animal will walk, and it will be tracked by software. Everything will be tracked. So if we move to the next slide, I think I'm taking a little bit extra time. So just take next slide. Please move to the next slide, Sushant. Some issue? Okay. Can you move to next slide, Sushant?
Sir, it's not getting next slide, sir.
Why? Okay, just okay. Okay, so yeah, fine. This is next slide, fine. So now we can see why there is a lack of spontaneous recovery in spinal cord injury. Because we probably all of us know that regeneration in CNS is very difficult process, and almost all of us were reading in different that neurogenesis is not easy in CNS. In PNS, it is reported. So that is the main reason. Second thing is that the endogenous repair is different in adult and neonates. And in case of adult, you can expect very limited repair in the CNS. I am talking mainly about CNS. Also, there are very limited compensative plasticity, and also there are kind of mainly if you see there is a after injury there are certain kind of molecule which got upregulated. So those molecule are some kind of anti-growth. So one of the example is no-go. So it won't allow the neurons to grow. That is called no-go. And also apart from that, there is a inhostile environment because of the presence of cystic cavities, fibrotic scars, lack of growth factor, and presence of lot of growth inhibitory molecules. That is one of the reasons. So if we move to the next slide, please move to the next slide. Okay. So if we see CNS injury, we need to fix whatever is left, whatever we have. As I mentioned to you, when we have someone have any kind of injury, that particular area of the spinal cord or brain will be damaged. So we need to prevent the further damage. So for that, we need to prevent the cell death. We need to promote axon regrowth. Even though people write like this, but promoting axonal regrowth is very impossible, highly impossible till now. So what we can do, we can do neuroprotection. We can prevent the further damage of the neurons which are nearby at the injury area. So it's like you can protect the neurons which are still intact, which are not damaged. So also you can also confirm to remove the blockages. So for this you can have approach which is strong anti-inflammatory, neuroprotective, anti-emetic. Second approach is, as I mentioned to you, imagine a road which is having a strong, which is having a hole in the center. Now, if you want to fix it, you need to build around it. You need to fill that particular gap. So for that purpose, there are many approaches like tissue engineering, biomaterial, cell therapy, which are well established, and it really helps to build the damaged area. So you can engineer different kinds of cells, and you can fill the cells in that particular area with the help of biomaterial scaffold, and you can build around it. So usually if you see the last 5 years, the biomaterials and scaffolds and tissue engineering is having high potential in regeneration of the spinal cord. So if we move to the next slide, we can see the main progresses toward the neuronal repair and regeneration. So we need, as I mentioned to you in the initial slide, that acute, secondary damage and chronic injury, these are different. So we need to design the strategy which are focused on all approaches, and they should be, as I mentioned to you, they should be very strong anti-inflammatory, prevent the glial scar formation, repair the neuronal tissue, prevent the further damage of the neurons. So most of our therapy will be either treating with the acute, preventing the further damage, preventing the secondary damage, and preventing the chronic injury. So this is kind of a process toward the neuronal repair regeneration. So for that purpose, we have different kind of cell-based therapy, stem cell therapy. If we move to the next slide, so we can see usually most of the stem cell therapy, including the MSC, these are the mesenchymal stem cell, Schwann cell, neuronal stem cell, olfactory enchanting cell, oligodendrocyte precursor cell. These all have shown potential in preclinical model, in animal model. However, most of these therapy did not have any significant effect in clinics. The long-term safety is not reported. The reason is very simple. If you inject the stem cell at the injured area, because of the hostile environment in the injured area, because of the inflammatory environment, the cells won't be proliferating. They might change from one phenotype to another phenotype, which you don't want for repairing. So that is one of the main problems with the stem cell. So people have used different approaches. If you move to the next slide. So we have, like, move to next. I already explained this. Please move to next slide. So to overcome the limitations, as I mentioned to you, that once we inject the stem cells, most of the cells will be washed out. They have very poor survival rate because of the presence of strong inflammation. Also, stem cell have different MSC, MSC1, MSC2, and so they can trigger immune responses. So we use some kind of immunosuppression, which might further weaken the immune system. And also, as I mentioned to you in the early slide, that spinal cord injury pathology is very dynamic. From acute, subacute to chronic, it changed drastically. The approaches should be focusing on all aspects of spinal cord injury, including from acute, subacute to chronic, strong anti-inflammatory, preventing the further process of the neuronal cell, and also preventing the glial scar formation. So for this, the exosomes can be used as one of the promising therapeutic agent, and these are free from any kind of cell. So these are cell-free regenerative medicine. They have all beneficial things from the stem cell, but they are not having any problems of the stem cell. They don't have any problem with the immune rejection. They are very small, so it will not be trapped in the lungs or liver. They will be directly reaching to the injured area by direct injection or IV. So you can avoid most of the problems of stem cell with the help of exosomes. So if you move to the next slide. So this is one of the approaches. So we published this paper in Nano Letter, which is having an impact around 14. So here what we did spinal cord injury, and we used some kind of approaches, and we use magnet as a guidance. And in the exosomes and in the nanovesicle, we also have iron oxide nanoparticle. So it become very specific to the target. So when we have magnet, and once we inject intravenously, the iron oxide will go toward the magnetic side. So this can be easily translated into clinics with the help of MRIs. This can be done. So we have already reported this approach, which is one of the approach which we recently published. If we move to the next slide. So we are mainly working in microtubule dynamics. We are trying to understand the neuron endothelial cell crosstalk, and also we want to confirm different approaches which are useful for regeneration. So I believe my time is about to finish, so I will be like in next 5 minutes I will be wrapping up this all thing. So basically we use different approaches, and we have worked in different kind of mainly therapeutic approaches, including the ion channels. So recently we published one strong paper in Journal of Neuroscience, and we show that the expression of TRPV4, this is an ion channel which is a mechanicosensor, osmosensor, and thermosensor. So it get upregulated with the help of it get upregulated in case of traumatic injury. So we already reported that spinal cord injury cause activation of this ion channel. So if we block this ion channel, we may have certain kind of protection. So this is one of the approaches. So one of my recent grant is focused on this. So we are trying to study the effect of myresin 1. Myresin 1 is a kind of uh, specialized pro resolving mediator that is called SPM. So these SPM, we if we move to the next slides. Okay, next. This I will explain. Yeah, next slide. Okay, so just next one more. Yeah, okay. So if you see here, so usually PUFA, these are polyunsaturated fatty acid. So these are released after any kind of damage. And there are many kinds of PUFAs which are reported in the CNS. So docosahexaenoic acid DHA and icosapentaenoic acid is like these are very famous one. These are the omega-3 fatty acid. And there is one more arachidonic acid, that is omega-6 fatty acid. So people have already shown that these omega-3 and omega-6 are having antagonistic effect on inflammation. So if we can have any approaches which can increase omega-3 fatty acid, it might give protection. So recently we published that resolvin D1 can be a strong inhibitor of inflammation in spinal cord injury. So in the current recent project, what we are doing is we are checking the effect of myresin 1. So myresin 1, if you see here, myresin is MA is macrophages, RES will resolve, IN is inflammation. So something which is coming from macrophages and resolving inflammation. So understand that anti-inflammation and resolution of inflammation is totally different concept. In resolution of inflammation, we are trying to restrict the entry of neutrophil by increasing the microglia or macrophage at the injured area. And these microglia or macrophages will eat the neutrophils which are already damaged. But in case of anti-inflammatory, we are blocking everything. We are blocking neutrophils, we are blocking microglia, we are blocking everything. So that is anti-inflammation approach. But pro-resolving approach is a little bit different. It only very specific to resolve the local injured area, not unnecessary causing the complete anti-inflammation. So this approach is a bit different. So here we are checking the effect of myresin 1. If we move to the next slide, we reasoned that myresin can be one of the potent anti-resolution factor, which is already reported that it can have a strong effect at very low doses. These are the metabolite of omega-3 PUFAs, and also we also know that there is a change in the concentration of these mediator in the lesion spinal cord. So we hypothesize that these particular myresin 1 can inhibit the TRPV4 expression, because we already reported this expression. So if we go to next slide. So first we confirm the concentration of DHA in the plasma and a spinal cord after a spinal cord injury in rats. So if you see the image in front of you, you can see C and D are the quantification of DHA concentration in plasma and spinal cord. So we can observe decrease concentration of DHA and in plasma as well as spinal cord. So one can expect the concentration of omega-3 fatty acid is decreased after traumatic injury. So if we can restore this, we can have a strong like resolution of inflammation. So if we move to the next slide, based on the docking study, we confirm that myrcin 1 can bind with the TRPV4. And we have already reported that TRPV4 was the channel which is expressed at early time point of injury. It is a strong osmosensor, mechanicosensor, and thermosensor. So it get upregulated at acute phase of the injury. So we can see after injury there is an increase of TRPV4, which is reduced by the treatment of myrcin 1. If you move to next slide, we can see the myrcin also reduced the expression of most of the cytokines and chemokines, including interleukin 6, interleukin 1 beta, TNF alpha, CCL2. These are the CCL2 and CCL3 are chemokines. So basically, it decreased the production of these pro-inflammatory cytokines and chemokines. So if we move to the next slide, so here we also confirm that basically it is reducing the infiltration of neutrophils, further infiltration of neutrophils. So if, as I mentioned to you, neutrophils can drastically change the pathology by releasing lot of cytokines, chemokine, and directly acting on the tight junction. So once we block the neutrophil infiltration, we can block recruitment of cytokines, chemokine, and also we can block the tight junction. We can prevent the disruption of tight junction. So we showed that the treatment of myrcin 1 can prevent the blood spinal cord barrier damage. So here you can see podocalcin CD45. So CD45 is specific for the neutrophils. Podocalcin is a kind of marker which is kind of you can see whenever there is a kind of barrier disruption, you can expect lot of infiltration. And on the D section, you can see ZO1. ZO1 is zone of loading, it is a tight junction marker. So you can see the treatment of myrcin 1 increase the expression of these. If we move to the next slide here, so also we can see the presence of ECM, that is extracellular matrix, and endothelial damage after a spinal cord injury. One can expect lot of changes in ECM because something is changing at the injured area, it will drastically change in the surrounding area. So if we want to have something to be protective in spinal cord injury, we can have a approach where the endothelial cells should be preserved, because endothelial cells are directly responsible for neurons. Most of the, if you see, all neuronal source is glucose, and the glucose is coming directly from the blood vessel, and these blood vessels are endothelial cells basically. So you have to protect the endothelial cells. So if we see here in summary, we can say that myrcin 1 are also very effective in prevention protection of endothelial cell and also for further damage. So if we move to the next slide, so we can see a kind of scoring functional recovery, improvement of functional recovery, and also prevention of gliosis, as we discussed in the previous slide, the glial scar formation. So basically, if we summarize this, so we can move to the next slide. So we can say that using this approach, we confirm that the omega-3 fatty acid, PUFAs, decreased after traumatic injury. And if we can restore the level of PUFAs, we can have better approaches. So we can use different combination of like either resolvins, myrcins, or there are protectins. We can use those, and we can protect the spinal cord, because these advantages, they are endogenously present, but the problem is after injury they go down. So basically, if we can at any means or by any method, if we can protect or if we can prevent the this damage, we can have better approach. So we can move to the concluding slides. So please move to the next slide. So here I want to acknowledge to my PhD students and my master students which are working with me. And I want to thank to Sir for giving me the grants, Naiper Ahmedabad and Department of Pharmaceuticals for kindly for giving me the generous grant and support which is required for finishing these studies. So thank you very much for listening, and I took little bit extra time, so sorry for that. So Dr. Karuna, ma'am.
No problem, sir. It's great pleasure, sir.
Okay.
Thank you for your valuable speech.
Thank you. Thank you. So,
Participants, if you have any queries, you can ask, sir.
yes, I will be happy to take any questions. If you have any questions, please feel free to ask me.
Dear participants, if you have any queries, you can unmute yourself and ask. Sir is ready to answer you.
ट्रांसपेरेंट
Sir, I have a small query, sir.
Yes, ma'am.
Sir, if a person if a person is under paralytic stroke, sir, due to smoking or due to any other issues, not because of any this
Okay.
accidents like that. It is because of smoking, clot has occurred in the brain and he is paralyzed. Is there any chance for his, recovery, sir? How much will
It
be the
depends
chance?
on the as I mentioned, there are many treatment approaches because your question is more toward the stroke side.
Yes, sir. Yes.
So I think the streptokinase or these kind of things are available, but it all depend on that how much is the extent of damage, and apart from that, you someone have to also consider the rehabilitation therapy approaches. These also. So usually streptokinase work well if it is giving immediately 24 hours. So time video, the time frame is very very important for any treatment of injuries, including stroke. So time frame is play very crucial role. So if you have if you have patient admitted to the hospital within 3 to 4 hours of the first attack, probably the chances of survival is very high and recovery is also very high. But if the treatment is delayed, it takes some time. But if, as you are mentioning, that it is only because of the smoking, not because of some other factor, probably you need to confirm with different kind of technique which is currently available with MRI scan, check the damage, how much is the damage, and we can someone have better clinical approaches. And I hope that definitely it will be having better protection, because these days science have changed a lot. Many things are coming into the picture and many new modalities are available.
So whatever treatment they give in the first few hours, that is more important.
Yeah, very important. So because the first time frame will decide the pathology, and pathology all depend on the initial 12-24 hours. As I mentioned to you that neutrophils and these all are crucial in early phase of the spinal cord or any traumatic injury. So early phase is very, very crucial.
So thank you for explaining us the spinal cord model and in a very simple manner and easy to understand.
Thank you, ma'am.
So it would have been more better if we had a training program also on this, sir. But
Yes,
due to
maybe.
the time constraint.
Yeah, sure, ma'am. Yes.
Yeah. So next time we'll definitely plan to have a continuous session, 1-day session, so that you can even show the practical skills to our participants, sir.
Definitely, ma'am.
It was pleasure having you in our FDP, and we are looking forward for collaborating with you in different drug discovery process.
Thank you.
Thank you very much, sir.
Thank you. Yes.
And if there are any queries, you can ask, sir, or you can post in the chat box. We'll forward to the sir.
So, ma'am, if nothing, then we can start with the next session.
Yes, sir. Thank you very much, sir.
Thank you. Thank you, ma'am.
If there are any queries, I'll forward
Yeah,
to you
sure,
later also.
Okay, ma'am. Thank you.
Thank you very much, sir. Thank you.
Thank you.
Thank you, sir. Thank you for your valuable speech.
Thank you, sir. Dear participants, we have our next speaker, Dr. Digvijay, sir, from CCRH, New Delhi. Over to Jyotirmay. Jyotirmay, madam, you can start the program. Second.
Yes, ma'am. Yes, ma'am. Yes, ma'am. Am I audible, ma'am?
Yes, you are audible, Jyoti.
Welcome to the third day online international faculty development program, second session. I am honored to introduce our today's chief guest, Dr. Vijay Verma Garu, who is a research officer, coordinator, drug standardization program, Central Council for Research in Homeopathy under the Ministry of Ayush. Sir is currently working as a research officer at the Central Council for Research in Homeopathy, New Delhi. He has He is also a coordinator drug standardization program of the council. He has extensively worked on the drug standardization program, research programs of CCRH on various medicines used in homeopathy. Previously, he worked as assistant research officer at DDPRCR, Noida, 2016, and assisted in development of monographs for homeopathic pharmacopoeia in India. He is actively involved in standardization of medicinal plants, chemicals, metals, minerals used in homeopathy. Presently, he is running one project funded by Council and also coordinating more than 10 assigned projects by the Council in different fields of botany, chemistry, pharmacology, and preclinical research. He has authored 5 books on drug standardization and has 14 articles published in peer-reviewed journals. I am honored to welcome you, sir. Over to Dr. Digvijay, sir.
Sir, good morning, Vijay Verma, sir. Sir, we are not able to hear you, sir. You are not audible. Susha, Jyoti, can you hear, sir?
No, ma'am. No, no, ma'am. Sir, you are not audible, sir.
Hello, sir.
No, sir, you are not audible, sir.
No, I am not mute. Audible? Now? Speakers are coming. Not audible. Actually, everything is there. Now?
Now you are audible, sir.
Okay, okay. Very good morning, all of you. Thank you, Dr. Karnasri ma'am, for inviting me in this faculty development program. I welcome on the behalf of Central Council for Research in Homeopathy to all of you.
Thank you, sir. Thank you for accepting our invitation. And we are very privileged to have you here in our FDP, sir. This is actually the second session in our today's program, sir.
Okay, okay. Can we start now?
Yes, sir.
Yes, sir. You are audible, sir.
Is my screen visible?
Yes, sir.
Yes, sir.
Respected madam, as desired, the topic for this session is herbal drug standardization in homeopathy system of medicine. I want to tell a little about homeopathy, and then after we will start for drug standardization, because this is a alternative system of medicine, and many people are taking medicines but exactly not knowing what is the system and from where it is originated. And this is the alternative system of medicine, and which is serving over two centuries. This is rapidly growing, considered second most popular system of alternative system in our country after Ayurveda, which is being practiced all over the world, almost all over the world. Homeopathy derived from two words, homeos means similar and pathos means suffering. This principle was first described in Hindu writings over 3000 years ago, also mentioned by Hippocrates, Galen in 2nd century and Nicholas in 16th century. More recently, research by German physician Dr. Samuel Hahnemann, who developed the homeopathy, and he is also considered as a father of homeopathy. It works on the principle similia similibus curantur, which means likes are cured by likes. Treating disease with remedies prescribed in minute doses, which are capable of producing symptoms similar to the disease when taken by healthy people. For example, some examples are there, but these are some examples for understanding, but the methodology what is using in homeopathy is different. As for example, if I am taking one medicine, we have to go for drug standardization, followed by drug proving, followed by clinical verification, clinical research, then it comes into public. For example, if similia principle, if I am saying that if I am peeling the onion leads to sore and with itchy notches and sneezing, in that case, allium cepa is used to treat fevers and colds, because cold symptoms are similar to runny noses and it is in eyes. If person is suffering from the same similar symptoms, the allium cepa can be given. Similarly, needle stings produce a burning, itchy wheals on the skin. Artica urens is a good remedy for similar skin lesions. Similarly, arsenicum poisoning, vomiting. Similar poisoning, similar to vomiting and diarrhea with burning pain and chillness. Arsenicum album is very effective in gastrointestinal and food poisoning diseases. If we are comparing the homeopathy and allopathy system, homeopathy is a physics theory in the remedy of preparation. Different, and each individual needs a special and unique remedy. For example, if I am suffering from fever and another person is suffering from fever, but it is a possibility that belladonna, for example, belladonna is a medicine which may act on us but may not act on another person. because this medicine is also depends upon the individualization, and it is a unique remedy. Homeopathy stimulates the body system to get rid of these diseases, and allopathy, this is a follow the chemical theory. Medicine are generic, not specific. If suppose that I am giving paracetamol, it may work on me also and work on another person also, and suppress the disease by concealing the symptoms. This mostly the alternative systems are also regarded as these are the medicines which treat the disease, not the suppress disease. But in allopathy, it is considered these are the management, not the remedy. In homeopathy system of medicine, if I am saying talking about the sources of homeopathic medicine, then these sources may be natural sources as well as physical sources. In natural sources, these sources can be plant origin, animal origin, nosodes, sarcodes, metals and minerals, and synthetic chemicals. For example, plant origin, we are taking either directa indica or linsipa, belladonna. These are the plant origin. Animal origin drugs are many, just like beta orientalis. Nosodes are the special type of medicine which are being prepared from the diseased tissue. Suppose, for example, the many medicines are there, just like bacillinum, tuberculinum. Tuberculinum is mainly made from the sputum of the diseased patients. Sarcodes are the animal origin healthy secretions. Just suppose, for example, these are the for example adrenaline, and metals and minerals just like cuprum metallicum, cuprum metallicum, argentum metallicum, and synthetic chemicals may be any other what is synthesized in the laboratory. Similarly, the physical energies just like magnetism, electricity, X-rays, and radium. These physical categories are kept in another category which are called imponderabilia. This is the another system of medicine which is also used in medicine, but this is not much more used in comparatively the traditional homeopathic system, where the medicines are made from natural sources. As per homeopathic pharmacopoeia of India, the homeopathic drugs may be, as previously mentioned, plant chemicals, zoological, and nosodes. In plant origin, 716 medicines are used. Nosode are 16, zoological origin 44, and chemicals are 335. These are the pharmacopoeia resources. The homeopathic pharmacopoeia of India is a legal document where the manufacturers have to follow the rules and regulations and method of preparation what is mentioned in homeopathic pharmacopoeia of India, similar to Ayurveda pharmacopoeia of India, Siddha pharmacopoeia of India, Unani pharmacopoeia of India. We also have homeopathic pharmacopoeia of India. We have 10 volumes published till date, comprising 111 drugs. The plant-based homeopathic drug sources may be prepared from whole plant, may be prepared from stem, may be prepared from leaves of plants, prepared from flowers, fruits, seeds, roots, barks of root and stem, etc. I will give the example in another slides. And method of preparation is also different from another system. Allopathic system where we take the compound and give to patients, but here is a different method of preparation where vegetable, mineral, and biological materials are filtered or make a solution, extract and filtered to make mother tincture, just like hydroalcoholic extract, similar to. Now we start the process of potentization, where liquid potency and solid potency both are prepared. Mostly the insoluble minerals are titurated, and after some succession we prepared soluble powder form and dissolve with alcohol and make liquid potency. This is called the process of potentization, which is mainly used in homeopathic system. Dynamization is a process by which the medicinal properties which are latent in natural substances while they are in fluid state become allowed and then enabled to act in almost spiritual manner in our life. Potentization is a process of strengthening the power of remedy by succession. Here we using mother tincture potency, just like you went to a medical shop and you are thinking that just give me LMC part 30C, LMC part 200C, LMC
background, special focus on neurosciences. His primary research areas is to find out the target of endothelial protection or stabilization within penumbral microvasculature.
Not audible. I think you are asking something. Sir, may I continue? Dr. Kanashri ma'am, may I continue?
Sir,
You can continue, sir.
I think some queries were there, therefore I stopped.
Sir, you can continue, sir. There was some issue in the YouTube channel was opened unexpectedly. Please continue, sir.
Okay.
Thanks.
Here we medicines are prepared, and this is a special method of preparation. In case once we start the dilution, where what are the mentioned, the dynamization and potentization. In each dilution, what we do in potentization, we take 90% part of alcohol and 10 part of mother tincture, and we sucker or 10 times, and we make potentization at 1C. And in another step, we again take 10 ml of drug and 90 ml of alcohol, 10 times suckers and prepare 2C. Similarly, we go to 1C, 2C, 3C, 6C, 12C, 30C, 200C, and we can see that on succession, the amount of medicine is decreasing. But in homeopathy, strength of medicine is increasing. Means 30C is less powerful than 200C. Although the content of the medicine or the content of compound is less in 200C, but the action of that drug is more in 200C. As previously discussed, that once medicines are prepared, these are given to healthy volunteers, and what the symptoms arised from that healthy volunteers that are clinically verified and given to the diseased persons. Now we go to the process of drug standardization. This is almost common in all the systems, whether it is allopathy, homeopathy, Ayurveda, Siddha, Unani, or any other traditional system, but the drug standardization is most common. Suppose that you went to a doctor and tell, sorry sir, your medicine is not working. Although the doctor has given the medicine what is prescribed in the system for the treating the disease, but it does not work on the patient. There are two reasons: individualistic approach, as I previously mentioned, and another approach which is related to the quality and method of preparation of drug. It means you are giving a branded drug and quality is good, medication is good, but this may not act on the patient because the quality or the correct plant species or the chemical has not been used in preparation of that medicine. This is also important aspect. Therefore, the quality of raw material, the genuineness of the plant, and the method of preparation, all the three aspects are responsible for the effective medicine. The standardization of drug means confirmation of its identity, determination of quality and purity, and detection of nature of adulterant by various parameters like morphological, microscopical, physical, chemical, and biological observations. In standardization of homeopathic drugs in pharmacognostical aspect, we perform microscopical parameters, microscopical parameters. In microscopical, just like shape of material, suppose that we are taking the plants, shape of the plant, size of leaf or flower, external morphology and markings. Similarly, in microscopical analysis, the qualitative studies, quantitative studies, powder studies, and fluorescence analysis of that drug. Similarly, in physicochemicals, in physical appearance of the chemicals, moisture content, extractive values, ash values, pH values, alcohol content, specific optical rotations, specific gravity, organoleptic properties of raw drug or chemical, just like that, what is the taste of that drug, what is the odor of that drug, texture, color. In chemical observation, qualitative and quantitative tests are performed to identify and detect the secondary metabolites. The chromatographic techniques, for example, HPLC fingerprinting, HPLC for quantitative analysis, chemical profiling and gas chromatography for volatile oils, and UV visible spectrophotometer for lambda max determination. In biological origin, suppose that we have taken authentic raw drug, but some contaminations are there. Some it is attacked with pathogens, then we have to perform the microbial contamination also to find out the total viable aerobic counts and determination of pathogen what is attacked on that drug. We have to set the parameters for that plant. And for biological identification, we perform the pharmacological as well as toxicological studies. In pharmacological studies, we study the efficacy of the drug. Suppose that what it is anti-epileptic, anti-inflammatory, anti-diabetic, anti-diarrheal, and other parameters we can find out. In toxicological, we perform the safety of that drug, how it is safe. For example, Nux vomica, which is a very, very poison, deadliest poison, but this is given in homeopathy in ultra high dilution forms. This is very good remedy for the diarrhea and dysentery, but this is for giving the patient and for validating that drug. We have to perform for the acute toxicity, subacute toxicity, and chronic toxicity of that drug. After that, we recommend for medicine to patient. I am giving an example of two raw drugs which are almost similar. In left side and right side, almost show similarity. And these are the commercial sample, and one sample is what are from our research council at from Fuji, and one is left side. This is commercial sample what we have procured from the market. Morphologically, these are the similar drugs, but once we perform the anatomy, we can see the clear difference. The wing pattern of the drug and patches of lignin deposition or secondary metabolite deposition, which is not present in genuine authentic drug. These are the basic parameters where we can discard the sample on the basis of just studying the microscopical studies of that drug. These are the some important criteria for the quality: identity, purity, content or assay, safety, and efficacy. These are the main criteria. In identity, I previously mentioned authenticity of plant material, purity, whether it is pure or it is contaminated with another plant material. For example, other adulterants are there, spurious drugs are there, and level of specific phytochemicals. Homeopathic medicines are prepared from plant kingdom. Suppose that Coffea cruda, Brownie alba, about 60% are drugs in homeopathy are used from plant origin. 20% are from mineral origin, just like Kali carbonicum, which is potassium, Natrium muriaticum, common salt, Silesia, common sand is there. These are, for example, Natrium muriaticum is we are using in common days. This is normal we are taking, but this is a very good medicine for many diseases. Many diseases. Therefore, in homeopathy, the method of preparation and drug proving is a very important part for determining the efficacy of drug. Remaining 20% medicines are prepared from animal origin. For example, Plata orientalis, Tarantula hispida, Apis mellifica, Biforana, and microbial tuberculinum, cephalinum, and imponderabilia, certain energy sources just like magnesium, magnetism, X-ray, and radiation, etc. For drug standardization of plant, we perform these parameters and we publish in the form of pharmacopoeia and also in form of books and manuscripts. First, we mentioned the drug name, botanical name, synonyms, family, and common names. Its description, its distribution, where it is distributed. Part used, what are the part used? Its microscopy, powder characteristics, chemical constituents, foreign matters, lot of dryings, total ash, acid insoluble ash, water soluble ash, extractive values, identification, assays and tests for heavy metals and method of homeopathic preparation. These are the common methodologies what we are using. Collection and identification, authenticity of material, microscopical powder analysis of raw drug. Similarly, plant-based homeopathic drug sources may be from whole plant, stem, leaves, as previously mentioned. Many parts may be used in homeopathy or another system, depending upon the efficacy of that drug. The collection of plant material is a very important source and a very important when we have to collect and where we have to collect. Where we have to collect, for that we have good collection practices, protocol, what we are following. For example, root and rhizome, if we are collecting, we have to wait for the end of vegetative period or in autumn. Bark we prefer in leaves we prefer at the flowering stage. Herbs and whole plant we collect in such a way that flowers are there, fruits are also there, and fruits and seeds are collected when these are fully ripened stage or especially mentioned in pharmacopoeia. Mostly we prefer to collect the material from natural sources, but many cases where the diversity affects, then we prefer for cultivation of plants, but we try to not use chemicals and pesticides, and we try to cultivate in similar to natural origin sources. Plant material should be collected by hands, especially in wild plants. Collected raw materials above the ground should not come in direct contact with soil to avoid any contamination. Otherwise, the chemical parameters, just like heavy metal analysis or ash value, may be vary. Underground parts are, if underground plants are used, then adhering soil should be removed from plants soon as they are collected. And collected plant material should be placed in clean baskets, mesh bags, otherwise well aerated containers, and these should be air dried without direct contact of sun. These are some examples of raw drugs which are used in homeopathy. Just like this is fruits, and this is wood, leaf, whole plant. In whole plant, we can see that each parts are there. Leaves is also there, roots are also there, stem is also there, flowers are also there, and fruits are also there. This is the ideal whole plant raw drug where we can prepare the quality medicine in rhizome, and these are the seeds of Paphagoda. Preservation of plant materials this is also very important. Important. Plant materials should be preserved so that the active compounds will remain unchanged during transport and storage. Collection of raw material are preserved through common method, that is drying. But previously mentioned that this should be air dried, not in direct contact with sunlight, to avoid changing due to sunlight. Drying temperature should be between 30 to 50 degree and recommended to protect sensitive active ingredient. Drying method for laboratory is open shade area, but manufactured with large dryer of the tunnel where materials pass through stream of warm air. We suppose that we are collecting material which is very less quantity, we can go for normal air drying. But when we are using a lot tons of material raw drug, then we cannot go for natural process by air drying. Then we use dryer for that. And dried materials, enzymes are not destroyed, but they are inactive due to low water content. Store the crude drug in dry conditions and in closed containers. Crude drug is advisable to exclude light because some materials may change their chemical constituent in the presence of light. And also protect the crude drug from microbial and insect attack. If you are not drying properly, after some time we can see that there is insect attack. Therefore, this should be well preserved. In microscopical parameters, we mostly see the general characters, external morphological features, including diagnostical type, typical characters of plant part, including organoleptic characters. Suppose that if you are collecting the raw drug of bark of neem, we have to check on the basis of taste also. We have to mention also that this is bitter in taste, and what is external texture of raw drug. All the things we are performing. These are some examples of raw drugs. And in under microscopical studies, we study includes the anatomy of root, stem, leaf. In leaf, from petiole, lamina, and rachis, we cut the sections. We perform the micrometric analysis, just like vein isolate number, vein termination number, and under flower, calyx, corolla, stamens, endoecium, gynoecium, everything we study. In fruit, we perform the sectioning of epicarp, mesocarp, and endocarp. In seed, we study the endosperm and cotyledon morphology. Similarly, we perform the microscopic study of root and stem also. Diagnostical anatomical features of entire section from periphery towards center, including cellular inclusions in any other things is there. Just like suppose that we have cut the section and starch grains are present, we have to mention it here. Some crystals or idioblasts are there, we have to mention there. These are the diagnostical features. Under micrometrical analysis, stomatal index is used, vein isolate number, vein termination numbers. These are we are studying. This is the classical example what I am giving here. This is the plant of Hygrophila spinosa. We prepare the photoplates also, indicating the height of the plant. These are the leaf morphology, flower, fruit, flower, it spines, everything we are mentioning here. And these are the photos of our sections where internal morphological studies are being performed here. In case of roots, air chambers is clearly visible, and in stem, quadrangular stem is there. Vein isolate number, vein termination number, everything we are performing. Under powder microscopy, we are studying all the things here. These are the peelings of the leaves, but where we can see that studies, this is not clearly visible, then we perform the scanning electron microscopy of that the leaves also. Here these structures are visible. Similarly, these are the hairs present on the leaf, but these are not clearly visible. Then we perform the scanning electron microscopy of the leaf also. But these are the very advanced methodology. We study only if required. Otherwise, no need to go for advanced studies, because these are very sophisticated instrument and takes time also. This is the another parameters which we are trying to incorporate in our pharmacopoeia. This is the DNA barcode. The barcode of each plant species is different from another plant species. On the basis of DNA barcode, we preparing the barcode library at our council, and we authenticate plant on the basis of molecular analysis. These are some publications related to our pharmaceutical work. But we have performed our study here. This similar thing we replicate in our pharmacopoeia also. In pharmacopoeia, we have not mentioned the photography of that plant drug. Therefore, we publish in manuscript form also. In physicochemical, now we moving towards physicochemical standardization, where the standardization of plant drug, chemical drugs, and standardization of mother tincture and finished drugs is performed. Under the physicochemical properties, we study the foreign matter, loss of drying, total ice value, acid insoluble acids, water soluble extractive, alcohol soluble extractive, preparation of mother tincture, followed by the alcohol content, pH value of that mother tincture, weight per ml, total solids, identification by color reactions, TLC and HPTLC with and without standards, and lambda max of that study. This is the pharmacopoeial format what we are following. Melting point, boiling point, all the chemicals parameters we are studying here in form of chemicals. That's This is a high performance thin layer chromatography. I think everyone is knowing how it works. It is a under HPTLC, we perform the study and identify the marker compounds and quantity. Also, how much content of secondary metabolites is available. This is the example of Raufia serpentina, what we have performed in our laboratory. And we have found comparative study performed, A, B, C, D performed. And under quantitative analysis, we have found the concentration of riasanthine content in the sample. And we found that the market samples have much more content of riasanthine comparatively what we have collected from our garden, where we have find out the highest number of highest content of 0.134% in sample in our sample, and also we have published the manuscript in our IGRH. And similarly, we have performed the HPLC method for Coleus coli, which is very useful drug in homeopathic system. Now we are moving towards the clinical development of homeopathic medicines, where the clinical development. Before the 20th century, research in homeopathy was precisely conducted on healthy human volunteers for proving drug symptoms and for clinical verifications efficacy of drug in diseased animal individuals. No research was carried out to establish their beneficial effect scientifically. As previously mentioned, that drug is prepared and given to healthy volunteers. What symptoms are coming? We are giving the medicines to the diseased persons having same symptoms. But now we are moving toward the pharmacological studies also to find out the safety as well as toxicity study of that drug. The term regulatory aspect in Indian scenario, homeopathic drugs is also included in Drug and Cosmetic Act 1940. Therefore, it becomes imperative to generate the data of each drug for the therapeutic toxic effect in laboratory animals under Schedule Y drug of India before the drug is subjected to drug proving research in healthy human volunteers. Previously, we just prepare the medicine and given to healthy volunteers for the drug proving. But now before going to drug proving, we have to perform the safety and toxicity study on animal models also. The pharmacology is the science of drugs, where it derived from pharmacos means medicines or drugs, and logos means study. It is the study of substance that interact with the living systems through chemical process, especially through binding to regulatory molecules and activating or inhibiting normal body process. There are two divisions of pharmacology where we study pharmacokinetics as well as pharmacodynamics. Under pharmacokinetics, we investigate the liberation, absorption, distribution, metabolism, and excretion. Under pharmacodynamic study, we perform the physiological effects, drug action, and relationship between drug concentration and effects. Under pharmacodynamic studies, we perform the safety evaluation study, primary pharmacodynamic studies, and secondary pharmacodynamic study. In safety evaluation study is to investigate the potential of undesirable pharmacodynamic effect of substance on physiological functions in relation to exposure in the therapeutic range and above. Under primary pharmacodynamic study, the study of action and or effect of substance in relation to desired therapeutic target. Secondary pharmacodynamic study, we study on the model of action and effect of substance on not related to its desired therapeutic targets. Under preclinical trials or non-clinical trials, Laboratory tests for new drug substances usually done on animal subject to see whether the treatment really works and if it is safe to test on humans. The main goal is to determine the product's ultimate safety profile. Products may include new medical devices, drugs, gene therapy, solutions, etc. Why do we require the animal before administered to man? This is the main question, why we are doing the pharmacological activities. The main objective of preclinical evaluation are to determine and define the pharmacological effect not only prior to initiation of human, but throughout the clinical development to determine the ultimate safety profile of therapeutic drugs, to identify an initial safe dose and subsequent dose escalation schemes in humans. Then the preclinical studies are included screening tests to indicate the absence of particular pharmacodynamic activity, tests on isolated drugs, bacterial cultures to detect specific activity such as antihistaminic, anti-secretory, vasodilator, antibacterial studies, etc. Test on animal models of human disease, just like Kindle seizures in rats, genetically hypersensitive rats, experimental tuberculosis in mice, etc. General observation test, we perform drug is injected in tripling doses to a small group of mice, which are observed for overt hidden effects. Preliminary clues are drawn from the profile of effect observed. Under confirmatory test, we perform analogous activities for detailed study by more elaborate complex tests which confirm and characterize the activity. Other related activities also measure like antipyretic, anti-inflammatory in an analytic drugs, mechanism of action to find out the mechanism of that drug, systematic pharmacology irrespective of primary action of drug, its effect on major organ systems such as nervous, cardiovascular, respiratory, renal are worked out. Under pharmacokinetics, we study the dose response relationship, maximum effect and comparative efficacy with existing drugs is carried out. Under toxicological test, we perform acute toxicity, subacute toxicity, and organ toxicity. We will all the discuss in detail elaborate. In preclinical development, we perform in vivo activity also, in vitro activities also. Under in vitro activity, we perform the biochemical tests like enzyme activity tests, cell culture tests on cell, for example, cancer cell lines, isolated tissue type, example, mucosa models. In vitro toxicity, we investigate potential toxic effect in bacteria or cell cultures or in zebrafish. In preclinical development, working with cell culture, in vitro cell lines are derived from mammalian cells, can be used to predict specific aspects in vitro activities and to assess the quantitatively the relative sensitivity of various species, including in humans, in the biopharmaceuticals. These studies also be designed to determine, for example, receptor occupancy, receptor affinity, and or pharmacological effects, and to assist in the selection of appropriate animal species for further in vivo pharmacological or toxicological studies. Under safety evaluation, here we can see that once we go for the cell culture, and if we found the positive response, then we save the time selecting the more animals for sacrifice, and result can be interpreted with the cell cultures only. Under safety evaluation studies, we perform the acute toxicity studies, subacute toxicity studies, subchronic toxicity studies, chronic toxicity studies, teratogenetically studies, and carcinogenetically studies. We perform the OECD guidelines for testing of chemicals. Under acute oral toxicity studies, we perform the 420, 423, and 425 OECD guidelines for single drug. For 28 subacute oral toxicity study, we perform OECD guideline 407 for repeated dose. Subchronic oral toxicity study 90 days we perform OECD guideline 408, and chronic oral toxicity study more than 6 months we perform the guideline for OECD guideline for 452 for repeated dose. General guidelines and some methodology for traditional medicines come into practice by WHO in 2000, where we perform the acute oral toxicity studies for single dose. Long-term toxicity test, we perform the single administration or repeated administration for 1 week, less than 1 week, to 2 weeks, or to 1 month. Repeated administration between 1 week to 4 weeks, or 4 weeks to 3 months. Repeated administration between 1 to 6 months, or 3 to 6 months. Long-term repeated administration for more than 6 months to 1 year. Sorry. Under safety evaluation study, we perform the potential of undesirable pharmacodynamic effect of drug on central nervous, cardiovascular, and respiratory system, as well as to implement supplementary tests to evaluate other organ systems. Safety pharmacology core battery studies, they are called, where in brain we perform the central nervous system CNS studies, motor activity, behavior, coordination, sensory motor reflexes, body temperatures. In CBS, we perform BP, heart rate, ECG, repolarization, HERT, conduction. Respiratory, we perform the respiratory rate, tidal volume, O2 saturation. In preclinical evaluation of homeopathic medicines are animal models, where we perform the anti-infective, studies, under which antifungal, antibacterial, antiviral activities and antiprotozoal activities are studied. Anti-cancer activities, central nervous system studies are performed. Anxiolytic, neurotropic, anti-epileptic, behavioral, nootropic activities, neuroprotective, anti-stroke activities can be studied. In immune studies, anti-inflammatory, analgesic effect we can study. Wound healing activity we can perform. Immunomodulatory effect on drug may be studied. Anti-arthritic activity and anti-allergic activity we can study on animal models. Metabolic disorders can be studied. Hepatoprotective, hypolipidemic, anti-diabetic, anti-osteoarthritic, anti-obesity models we can studies. In urinary system, anti-urolytic study we can study. Cardiovascular studies under anti-hyperactive vasodilatory effect we can study. Why animal models are selected? This is the main question for preclinical studies. Why we are not going directly to animal models? The answer is species identity is known for mice and animal models. Uniformity in gene chemistry. Perinatal history is known. Design and balance sheet we can give. Hygiene ensured. Almost free from disease and docile. Therefore, we perform a study on animal models. Animal models can be inbreed strains, transgenic mice, knockout mice, congenic mice, as per database of 2008 of PubMed. And strains also vary from year to year. You can see here on the slide. These are the animal model mice with the strains: bulb C, ICR, NOD, ALS mice. Animal models in rat can be outbred, heterogeneous, diffuse pancreas, do not vomit. Vista rats, we can perform toxicity studies, aging study, creatology studies, metabolic disorders, other research we can perform. And in Spire-Dalway model, we can study neurobiological research and cardiovascular disease research. These are the some models where we perform a study on different models. Nowadays in 1970s, we start studying preclinical research on zebrafish model. In 1917, it was started in University of Oregon by George Stinger. Zebrafish information network he had developed, and over 5,000 researchers in 450 labs throughout 31 countries. Research has been performed till date. And in NCBI, we have under zebrafish model have about more than 114 publications. Some advantages are for zebrafish models, as these fishes are very small size and very short life and very short generation time, good reproduction capacity, external fertilization can be done, optically transparent embryo is there, rapid embryonic development is there, and high similarity and cellular structure, signaling and physiological with other high order vertebrates. Therefore, we start studying on zebrafish model also. The powerful model organisms can be genetic, developmental biology, toxicology, pharmacology, DNA repair, cancer. We can perform under diabetic mellitus. We can study cardiovascular system, central nervous system, gastrointestinal disorders, bone density, immune system, renal disorders. We can study under this model. But question is there: can we study the zebrafish models in homeopathy? Only very few publications are there in homeopathy. Only 6 to 7 publications are there, and mostly are from our councils. And this is a very new area for the homeopathy, where we are also start studying. This is the study what we have performed here. We start the anti-epileptic effect of PTZ model on Artemisia vulgaris, which is homeopathic drug, where he studied here you can see the effect of Artemisia vulgaris mother tincture 6C30C in anti-epileptic PTZ induced model. Under which we studied the effect of Artemisia vulgaris on zebrafish model, and we have found out that 6C potency of medicines have more effect in later stage like tonic colic and coronus stage, whereas Artemisia vulgaris at 30C has anti-epileptic potential action in all stages. These are the outcome of the studies that we have performed in our lab, and where we studied on Artemisia vulgaris and mother tincture 6C30C, belladonna, mother tincture 6C30C, belladonna 6C30C. And these are the different models that we have studied. And Cuprum metallicum, two methods are we have from the council we have found studied here. And in outcome, we have found out that Artemisia vulgaris, mother tincture 60 and 30C has anti-epileptic potential in PDZ-induced conversions. Artemisia vulgaris showed effect in later stages like tonic clolin and clonus stage, whereas Artemisia vulgaris 30C has some potential in all stages. Belladonna mother tincture is effective in stage 2 and 3. Belladonna 6C up to stage 4. And Belladonna 30 is anti-epileptic potential in all stages. Tecuta virosa, although this is a very good medicine and given to human beings for anti-epileptic effect, but in zebrafish model we have not found out any anti-epileptic effect. Similarly, in 33 we have not found any effect on zebrafish larva, also in zebrafish adult model. In Cuprum metallicum shows anti-epileptic potential in 60 and 30C. And Cuprum metallicum 60 showed anti-epileptic potential action also. These are the outcomes of our studies in zebrafish models. Therefore, this area is very new for homeopathy, where we are focusing to study on these models. Standardization of drug is very essential to provide good quality drugs of high efficacy and potency. Such kind of standardization studies are needed to promoting the safe use of genuine drugs, thus contributing to human health. Means the authenticity of raw drug following the pharmacological effects may be lead to quality of medicines. And at the last, this is the slokas from our Vedas. Amantram aksharam nasti, nasti moolam manaushadam, ayogyam purusho nasti, yojak sastatra durlabha. It means there is no letters in alphabet that cannot be used as mantra. And there exists no root or raw drug which cannot be used as medicines. Likewise, there is no incompetent or useless persons. Scarce is a person who knows how to make good use of all these. At last, thank you. Any query may be asked.
Dear participants, if you have any queries, sir is ready to answer you. So thank you for your valuable speech, sir. Sir, here one question. So how far suggestible homeopathic medicine for the onset of action instead of allopathic?
Sorry, sir, your voice is not audible.
Am I clear now, sir?
Your voice is not audible, sir. You can type your question in chat box. I will reply accordingly, sir. Your voice is not clear, sir.
Okay. Hello, good afternoon, sir. Hello. Good afternoon, sir. Am I audible? Am I audible, sir? Am I audible, sir?
The sound is echo, sir. We cannot hear it properly. You can type your question, sir. And,
Participants, you can type your question in the chat box if you are not audible. Please post your question in the chat box. We'll read out. Session is open for discussion. If any participant has a query, please post in the chat box.
you can ask any query, and if you want to ask anything from mail, I am sending my mail on chat box. You can directly ask any query related to homeopathy and drug standardization. You can write us an email, and we will try to revert on the same day.
Sir, I have a query, sir.
Tell me.
Yeah. Sir, are you accepting any consultancy work, sir? If we provide the sample, will you be able to do evaluation parameters and give us the results, sir? Is that type of consultancy possible with you, sir?
Yes, ma'am. We are performing here. We are performing.
How can we approach, sir? How can we approach?
You can write in an email to us and send a letter to us, and we can perform on the payment basis. No problem.
So at our institution level, we generally use normal microscopes only. But
Okay,
we don't have this scanning electron microscopes and high-end equipment we don't have in our institutions.
Yes, ma'am. Actually, for the publication purpose, these equipments are required.
Yes.
Suppose that we are legal binding, we are law making authority under Pharmacopoeia Commission of India, Ministry of Ayush. Suppose that we are making mandatory to manufacturers to perform the scanning electron microscopy for all drugs. That will be costlier for them, which lead to the burden on common man. Ultimate sufferer will be the common man.
Yes, sir.
Suppose that the manufacturer is performing SPTLC, then he is taking doing on payment basis, and suppose that he is charging for identification of 10 lakh rupees, then that 10 lakh rupees will be recovered from the drug of medicine what is being circulated in the market. Therefore, for high-end equipment, we prefer not to make it mandatory, but if required, you can do. If TLC is available, you can do the TLC, but if required, you can do an additional parameters to comply the GMP certification. Here also in my lab also we are trying to develop the scanning electron microscopy facility, but at present we don't have. But nowadays we are planning to develop a DNA barcode library. It means, for example, if we are performing the drug standardization of a plant which is new to the system, we have to know the correct species identification. In the future, if anyone want to collect the plant on a molecular basis, he can also find to collect that plant. Therefore, we are now in process to develop the DNA barcode library. One question is there.
Thank you, sir. Sir, one question is there in the chat box.
Yes.
For homeopathic medicine is suggestible for onset of action instead of allopathic medicine.
Ma'am, we cannot say 100% because this is the prescription by the doctors. We are just a drug standardization department. However, in many cases, it has been seen that allopathic medicines are also as fast as allopathic systems. But in most cases, it is regarded that these are slow acting. But the method of treatment and method of action is different from allopathy.
Thank you.
Sir,
Please
one more
explain
question.
ZBrush model they are asking, sir.
Actually, sir, please your email ID because this is very lengthy process, and if one lecture will be there again, then it is not possible to explain everything. But for in brief, we can say the zebrafish is the Denio rario, which we are using in our laboratory. We are giving medicines to zebrafish and see the effect, pharmacological effect on that model. This is very small fish, 2 to 3 centimeters, and these are very friendly. It means you can store and in very small lab. Very small lab required to maintain the animals, not just like to animal house. Only small chamber is there. We can aquarium is there. We can maintain thousands of fishes, and for experiment purpose we can select that fishes. Sir, please share your email ID. I will share the full process of zebrafish model. I will share it. You can write us an email also. I will share all the details related to zebrafish model. Okay, sir. I have got your mail.
Sir, how do we calculate expiry date for homeopathic medicine, sir? Is there any protocol or experiment?
Ma'am, for expiry date, we are following the rules and regulation of Drug and Cosmetic Act 1940. As per homeopathy system of medicines, nowadays there is no expiry for the potentized forms. No expiry. Many drugs are previously prepared by the Samuel Hahnemann, sir, 2,200 years ago. Now these are also used, and these are also effective. Okay. Because the theory of homeopathy is different from allopathy.
Yes.
It is diluted, ultra diluted form. And as per Avogadro limits 10 to the power minus 23, there is nothing. Avogadro hypothesis is there. But once you dilute, start dilution, the Avogadro limits ends at 10, 12 C. 1 C, 2 C, 3 C as previously described. And we are giving medicine at 30 C. In molecular basis, nothing is in in medicines what we are prescribing. But some theories are there that some nanoparticles are there. Some experiments also conducted by the council by IIT Bombay. In it is found that nanoparticles are there in medicines at 200 C, which acts on human body, and some other theories also there that mimicry is done by the molecules of alcohols and waters. These are the theories, but in practical, some proof are there. Therefore, the expiry in homeopathic system is not implemented nowadays.
Anyhow, every system of medicine, whatever is in use nowadays, including complementary and alternative systems of medicine, allopathy, the motto of all these systems of medicine is to make the quality of life better for a patient. So that is why we have used the holistic approaches term in our title also, sir.
Yes. Actually, one more thing very good in homeopathy is that many cases you have seen that drug reaction is there. Suppose you have taken high dose of paracetamol, drug may react. But in homeopathy system, very rare cases there are adverse drug reactions. Normally there is nothing. This is very good for our system.
So thank you very much for sharing your knowledge and accepting our invitation and being a part of this faculty development program, sir. We are very fortunate to have you in our program. And if there are any queries, I'll post to you, sir. And,
Okay. You can send
pass
an
on the
email.
audience participants.
We will reply. Okay.
Dear participants, attendance link was posted in chat box. Please fill by the clicking link. The session is ended.
There are 2 sessions also. Session will begin and we will continue the second session immediately after the first session is completed. After completing the 2 sessions, the attendance link will be posted as it has happened today. With this, we conclude today's session.
क्या चल रहा?
The session is ended. You can. Today's session is ended. Thank you.
Yeah.
एक players दो.
Tomorrow the session will begin at 10:30 a.m.
एक जिल्दार दो.